In the last lecture, we were looking at arrays and collections. Okay, and to briefly refresh your memory, when we declare an array, for example, if we wanted to create an array of integers, so once we put the empty square brackets, after whatever the data type is, whatever int or double, or if you wanted to create an array of students, okay, so that means we are going to create an array, right? Followed by name of the array. So if you wanted an array of size 5, you will say something like this, right? Then how many memory elements will this give us? This will give us A0, A1 up to A4. So 5 memory elements. And from that point on, you can store anything in one of these locations or read it. So it's pretty straightforward, right? Same way, name of the array, new double up. For example, if you wanted to create an array of size 10, you will indicate like this, right? Okay, what if you wanted to create an array of, let's say, 3 students? Then how would you say, for example, STA equal to new student 3, right? So does this give us the real memory for storing 3 students? No. What will happen if I try to do something like this? STA of 0 dot first name equal to, let's say, Bill. What will happen? Will the compiler allow this?
No.
Yeah, compiler will allow this. This is an array of students, so from compiler point of view, it's okay. But what will happen if you try to run it? It will come to this line and generate a runtime error. Why? Because as we discussed, what does this line do? STA will be created in the stack area, correct? And then in the heap area, we said create 3 students. But see, if we create a student like this, like new student, for example, we get the memory for all the fields. Like if the student class had 5 fields, it will give us memory for storing first name, last name, and so on. But here, there is no parentheses over here. So this is just a square bracket. So what does that mean? We basically created 3 references. This is STA of 0. This is STA of 1 and STA of 2. Okay. So we never allocated the memory to store the first name or the last name for each one of these students. So this is an array of 3 references. So far, this is an array of references, not an array of students. Okay. So it's our. So this is what we discussed in the last lecture, that creating array of a student class or any class object is a two-step process. First, you allocate the memory for the array. Then for each element of the array, you allocate memory for the object. Okay? So that's why this will not work. What's the proper way to do it? Either you can write a loop, or one at a time you can say STA of 0 equal to new student. STA of 1 equal to new student. Of course, if you had a large array allocated over here, this is not the proper way. So what's the more efficient way? We say for int I equal to 0, I less than STA dot length. As we discussed, anytime we create an array, we automatically get the length property and I plus plus. So now if we did STA of I equal to new student, it will work properly. Okay, so now if you did STA of 0 dot first name equal to whatever, it will let you store, right? So what did this green part do over here? very first time through the loop, I will be 0, so st of 0 equal to new student. So take a look over here. If the student has memory for first name, last name, and so on. Okay, so this is for one student, and we said sta of 0 equal to new student, so basically this will point over here, right? Very similarly, second time through the loop, sta of 1 equal to new student. So again, 5 fields will be allocated for storing the first name and so on. Okay, and then sta of 1 will point to this memory, right? And lastly, third time through the loop, sta of 2. So again, 5 fields will be allocated. So now this is what the memory will look like, right? So now once we say st of 0 dot first name equal to Bill, the computer will start from sta, then we'll go to sta of 0, then we'll go to the memory for sta of 0 and store Bill over there, right? Okay, so just keep reminding yourself, if you have to create an array of reference types, it's a two-step process. Allocate the memory for whatever size of array you need, then go into a loop, and one by one allocate memory for each object that needs to be stored in the array, right? Okay, so then we also discussed in the last lecture that arrays are fixed size. Okay, once you create an array, for example, if you created an array of 3 students, you can only store 3 students. What if as you are running the program, you wanted to store 2 more students, so a total of 5 students? Okay, so one possibility is we allocate more memory. So one possibility is if you needed later on to store 2 more students, this is what you will do. You will say student, let's say sta2 equal to, okay, this is an array. So sta of 2 equal to new student of 10 or 5, let's say, right? Okay, then for int I equal to 0, I less than sta2 dot length I plus plus sta of 2, sta 2 of I equal to new student. So we allocate memory for now 5 students, right? Okay, so now the first 3 students are already stored in this old sta array, correct? So we'll have to copy the data for all the old students into the new array. So sta2 is our new array, sta is our old array. So you will have to do something like this for int I equal to 0, I less than sta dot length I plus plus sta of I, sta 2 of I equal to sta of I. Okay, so we are copying the existing 3 students. See, sta of dot of length in this example will be 3, right? So the 3 students are now being copied into the new array, right? So since we have copied the data from the existing array into the new array, now we can do sta equal to sta of 2. Okay, so now whatever is sta of 2 becomes sta. So now you can go and start storing sta of, let's say, 3 dot first name equal to whatever, and so on. Okay, so the point is, anytime in your program, if you started with a initial size of the array, okay, and then you wanted more memory. So in plain English, what's the procedure? You allocate a bigger array. So if you take a look over here, what did we do? We allocated a bigger array, right? How much bigger it was in this example? Size 5. Original array was size 3. Okay. So once we allocate a bigger array, then what is this part doing over here? Copy data from original to new array, correct? Original was STA, new is STA2, so we are copying data one by one into the new array, right? So once we have copied the existing 3 students, this loop will go 3 times. Now, what's this part doing over here? Okay. Basically, we don't need the new array because in our code everywhere we were using STA. So now we are saying STA2 becomes STA. Okay, so new array becomes the old array. So that our code can keep using STA2. Otherwise, what will happen is if a few lines later you needed to allocate 10 students, you may call it STA3. So somewhere you're using STA2, STA3. So this way, once this part is done, okay, rest of the code continues to use STA just like we were using in the beginning. Okay, just like we were using in the beginning. Okay, so coming back to this point, even though arrays are fixed size, if we need more memory, we can create a bigger array, copy the data from the old array to the new array. But as you can see, this is not an efficient or a clean process. Okay? What if our needs keep changing? As we are running the program, we need maybe 5 more students, maybe 100 more students, maybe 1,000 more students, right? Of course, one option is start out by allocating a huge array, okay? But then that's a wastage of memory, okay? Because we may, especially if you are writing this code inside, let's say, a web server, and there are many clients connecting to the web server, then every client that connects will, if you allocated a 1,000,000 size array, so pretty soon your web server will run out of memory. Okay, so the bottom line is, if you already know that you will not need more than a particular size, then it's okay to use arrays for varying size needs. So if the demands keep changing, what's a better option instead of an array? Collection. So use collections. Okay, so I'll be introducing different types of collections as we go along. The very, very simple, basic collection, so one easy collection, as we discussed in the last lecture, is called array list. Okay, so internally, array list is basically an array of objects. Okay, so the array list itself starts out with a fixed size array, but if we keep adding more to it, periodically, internally, it will do this type of code. Okay, but you don't have to worry about it. It will do it automatically, adjust to give us more memory. Okay, so you can simply keep calling the add method to add an array. Okay, so one of the things that I will demonstrate to you soon is that collections are heavily used in modern programming. So regardless you're using C# or Java, you will see everywhere there will be abundance of collections. Okay. Now, the other good thing about collections is that collections are uniformly programmed. Okay, meaning every collection. So what I mean over here is, it doesn't matter if it's an array list or some other collection that I introduce later on. Okay, every collection has an add method. So if you wanted to add something to the collection, okay, you will call the add method. Okay, every collection has a remove method. Okay, every collection has a count property. So if you wanted to know how many elements are in the collection, you'll simply call the count property. Okay, every collection gives us an easy to iterate loop that I showed you last time called the for each loop. Okay, there's also, if you wanted to remove something at a particular index, okay, so you can also go and pick a particular position and remove it. Okay. Anytime we have like variable memory needs, we will prefer a collection. Okay. Now, because internally an array list is an array of objects, as we discussed, anytime we store something in the array list, it becomes an object. Okay. So suppose we did something like this. Okay, so suppose we wrote some code, array list, let's say a list equal to new array list. Okay, and suppose you did a list dot add 5. Okay, so what will happen to 5 as it goes into the array list? It will be converted to an object, right? So if this is the A list, 5 will be wrapped around as an object. Okay, remember last time we also briefly discussed the concept of types. We have two categories of types. We have value types and reference types, right? Value types are created on the stack. Reference types are created on the heap, right? Okay, so what is 5? When I say add 5, value. Is it a value type or is it a reference type? Value type, right? However, as it goes into the array, it becomes an object. An object is a reference type. Okay, so the technical terminology where a value type becomes a reference type is called boxing. So boxing basically means a value type becomes a reference type. Okay. Now the key concept to remember is boxing is automatic in C#. Okay, meaning you as a programmer do not have to do anything special. Okay, all you do is, for example, put it in the array list. Once it goes to the array list, it will automatically become an object. Okay, but what if we wanted to read it back later on? Okay, so what if later on I wanted to say int data equal to, let's say, a list of 0. So the very first element I wanted to read back. Okay, see if I read it back, what will it be read as? Object. As an object, right? So this will be read as an object. So the right-hand side is an object, left-hand side is integer. Will the compiler compile it? No, because C# is a strongly typed language. So the type of the left has to match the type of the right. Okay, so how can we satisfy the compiler? by typecasting it to an int. So whatever data type you store in the array list, as you read it, you have to typecast it to the same data type. Okay? So as we recover it, you can see the object, which was a reference type, needed to be converted to a value type, right? So that process is called unboxing. So unboxing needs to be done explicitly, meaning you as a programmer have to write the code to convert the type to whatever type you want. It's not automatically going to do it for you. Why? Because once again, it's a strongly typed language. Okay. Okay. Now the other concept that we discussed, which is important to understand with, especially with collections like ArrayList. Okay. So suppose after this, we do something like this: student S1 equal to new student, right? And then we do S1 dot first name and S1 dot whatever, right? And then we do a list dot add S1. Okay, so the second element we add is S1, right? Very similarly, suppose we create another student, student S2 equal to new student, and initialize some data in S2, and then a list dot add S2. Okay, so S2 also gets added over here. Okay, now suppose our goal was go through the whole list and print out the grade of the student. Okay, so the goal was find each student in a list and print the grade, or show the grade, whatever, right? Okay, so if we write a code like this for each student ST in a list, okay, message box dot show st dot compute grade, what will happen? Okay, first question, will it compile?
Yes.
Okay, the answer is yes, it will compile. So compile is no problem. What happens if as you run it? Okay, see what's the meaning of this student ST? So that means, think of this way, ST is a reference. What kind of reference? Capable of pointing only to a student or some object that is inherited from the student class. Okay? Remember, base class reference can point to a derived class object, right? So when we say for each student ST, we basically are creating ST, and one at a time we are pointing over here. Second time through the loop will point to the second element. Third time through the loop will point to the third element, right? So very first time through the loop, what is it pointing to? This is, in reality, even though it got typecast as an object, it's an integer, right? So can a student point to an integer, student type reference? No. So this is where it will generate immediately a runtime error. So as we discussed in the last lecture, one of the things you have to do is, if you are looping over a collection, make sure your loop variable is capable of pointing to each element in the collection. Okay, so what type of variable can point to a number as well as a student? If you cannot think of anything, pick object, right? So now we will modify the code, so this is not going to work. This will generate a runtime error. So our correct code will be something like this for each, object obj. And by the way, as you are typing object, you can either type it as with a capital O or a lowercase o. Okay, it's the same thing. Okay, same thing for a string, you can type it like this, or with a lowercase s. It's the same thing in C#. Okay, for object obj and a list. Okay, and now if we did message box.show obj.computeGrade, will this work?
No.
Okay, so let's take a look at the first part. Object obj. So instead of st, what type of reference we are creating now? Obj. Okay, can obj point to a number?
Yes.
Or a student, right? So it will be able to correctly point to each and every object. Okay. However, once we write obj.computeGrade, this will not compile. Okay. Why will it not compile? Because what type is obj? Object. Does the object class have a method called computeGrade?
No.
So that's why it will not compile, right? So this is where we need the same is-as operators or the use of reflection to make it work. So to make it work, okay, our code will look something like this for each object obj in a list. If obj is student, okay, then student st equal to student of obj and message box.show st.computeGrade. Okay, so we can either use the is operator or the as operator. So let's try to understand what this code is doing. Okay, for each object obj, so we are using an obj type of reference. So can it point to everything in our list? Since object is the base class of everything, sure it can. So as far as the criteria that our loop variable should be able to point to each and everything in the collection, so that's satisfied, right? Now we will check if obj is students. So very first time, once obj is pointing to over here, will it come back with a true or a false? False, because it's a number, it's not a student. So it will skip this part. Second time through the loop, obj is pointing over here. Is it a student?
Yes.
So see, obj now is pointing over here, right? Okay, we cannot say obj.computeGrade because the compiler will not allow us. So what we do is we create another, reference, student st. So we create an st reference and make it point to the same place obj is pointing to. So obj was pointing over here. We also make st point to the same place. See, if we don't say this, okay, if we simply say make st point to same place obj, what will happen? Will the compiler compile it?
No.
No, because the right side is object, left side is student. Okay, but we know obj is indeed pointing to a student. Otherwise, we will not be coming to this part. So we've already verified that. So to satisfy the compiler, we'll say go ahead, typecast it to a student. Now ST will point to the same place OBJ is pointing to. And now if we do st.computeGrade, we'll be able to accomplish our goal, right? What if I asked you, okay, in a couple of weeks you'll have a test. What if I gave you this code and say change it to using the as operator? Okay, so you guys should be very easily able to do that. For the as operator, what will it look like? Well, let me write it over here. For each object obj in a list, okay, we will do student st equal to obj as student, right? And then should we write message box.show st.computeGrade?
No, check.
We have to check because
Maybe it's not.
very first time OBJ is pointing over here. So if we try to convert it to a student, it will say it's not successful. It will give us a null as an answer. So always make sure you check for,
So it's not a problem.
then do message box.show. And st.computeGrade. Okay, so now that you have a good idea about storing data in a collection, being able to read it, okay, remember to read the data from a collection, you can use the same indexing as we do for an array. So if somebody said, get the third item stored in the array, how will you get that? A list of 2, because the first is a list of 0, then a list of 1, then a list of 2. Okay, even the you don't have to use the for each loop. You can use a regular for loop to index a collection. Okay, so that's another advantage. Okay, so now let's come back to our last part of basic object-oriented programming and take a look at the concept of indexers. Okay, so today we will finish the basic object-oriented programming concept and how they are supported in C#. So once again, goes into encapsulation, which is creating the class, public, private, protected keywords, inheritance, okay, virtual, override, abstract keywords, right? And then polymorphism, okay, which we further said goes into overloading and overriding. Overloading is within the same class, right? So this could be constructor overloading, it could be method overloading, it could be operator overloading, correct? Okay, and of course overriding further involves the virtual override, abstract keywords. And the other concept in overriding, especially from true polymorphism point of view, was that a base class reference can point to a derived class object. See, at that time, many of you were questioning why should we use a base class reference. I remember I was giving you an example of, let's say you have a class student, you had a class called grad student, which is inheriting from student, correct? Okay, so we were writing a code something like this: student st equal to new grad student. And then as we were trying to access the thesis field, I was saying this code will not compile, okay? Why? Because what type is ST? Student. And the student class does not have the thesis, even though we allocated the memory for the grad student, which does have thesis, right? So we can, again, using the is operator, as operator, we can check, is it pointing to a grad student? If so, create a grad student type reference and then try to assign the thesis, right? So very similarly, we will do something like this. If ST is, let's say, grad student, and then we will create a grad student GST equal to grad student ST. So we'll make GST pointing same place too, right? And then we'll do through GST, we'll set the thesis, okay? So anyway, at that time, some of you were saying, oh, you know, why do that? Why not just say grad student ST equal to new grad student, okay? In that example, perhaps we could do that and it would be okay. But overall, if this capability was not there, then we will not be able to store different types of things in an array list, as an example. So the only way we are able to successfully loop is because object happens to be the base class, and it can point to anything which is contained in the array list, right? So the point is, and again, as we keep going, you'll keep seeing more and more useful aspect of this capability. But this capability is extremely important for true polymorphism, okay? And because this gives us high flexibility in writing a code, for example, it gives us the capability that ArrayList can store any type of data in it, okay? But as we try to recover the data, as you saw, we need to use the is operator. We need to use the as operator or reflection. So part of polymorphism will not be useful if we do not have the is, as, and reflection made available to us. Because using these, then we can overcome the fact that a different type of reference is pointing to a different type of object. Okay. So anyway, last part which is remaining over here, under operator overloading, we already saw how we can overload operators and create a new data type, effectively a new data type such as complex, such as currency, right? Okay. Now the second part of operator overloading is what are called indexers. So as I had mentioned, indexers only make sense when a lot of data is involved, meaning an array or a collection is involved. Then overloading the square brackets so that we can easily access the data that we are interested in makes sense, okay? So now that we already have a background in arrays and collections, let's go see why writing indexers make our life extremely easy and useful. Okay, so to give you an example of the use of indexers, suppose we wrote a class called student. Okay, and whatever 5 fields we have and whatever the methods we have. Okay, now suppose we created a class called university. Okay, and of course, university contains a lot of students, right? So how will we store students in a university? We have two options. We can create an array of students, or we can create array list of students, which collection, right? So let's suppose our university will have 5,000 students, So we can create an array list and keep adding a student to it as needed. So one of the data fields over here will be array list, let's call it ST list, equal to new array list. Right? And suppose we provide a constructor public university. Okay, and let's pretend the code over here basically goes to the database, read all students, and populate ST list. Okay, so we haven't learned database programming yet, and hopefully next week you guys will learn the database programming. But anyway, for right now, let's pretend our code goes, reads the data from the database, and keeps adding a student to it. Okay, so now let's pretend this after the constructor is called, it has 5,000 students stored in it. Okay. Now, suppose you were creating an application, let's say the registrar's office or the department office, where if you go and say, you know, what's my balance or what's my GPA, so they will simply type your ID and let you know. So we wanted to create a similar capability. Let's say you type student ID. Okay, whatever 625371, right? And you click on search button, and this will simply, so this will go and give you all the details. What's your name? What's your address? What are your grades, and so on, right? Okay. So if you were to program this, right? What type of code you will write in the search button handler? Okay. So suppose, let me go over here. Okay. So suppose in our main form, okay, we already have created university U1 equal to new university. Okay, so as soon as the constructor is called, what will happen? This will populate the array list with 5,000 students, right? Okay. So anyway, now we create another form. If somebody clicks on it, okay, or in the main form, doesn't matter. Somebody clicks on the search button. So now we have another button handler over here. So what type of code will we write over here so that we can go and look for the student? Our typical code will look something like this, okay? We will say int student ID equal to, suppose this is called txt student ID. Once you created it, that's the name you gave it. So what will it say over here? txt student ID dot text, right? Okay. However, whenever we read data from a text box, it's always read as a string, right? But we want this to be converted to an integer. So easy way to do that is whatever data type you're converting to has a parse method. So if you did int.parse, so if you wanted to convert it to a double, it will be double.parse, okay? So whatever data type, call the parse method on it, that's one of the ways we can convert it to an int, and now we can store it in student ID, right? Okay, so then what will we do? We have 5,000 students in this ST list, right? So we'll have to write a loop. So we will say for each student ST in ST list, and then if st dot id equal to stid. So that's what we read from the text box, right? And so let me create a reference over here, student st match equal to null. So I initialize it to null. So if we do find it, we will say st match equal to st, and we will break out of the loop, get out of the loop. Okay. So now we will say if st match is not equal to null, or first let me put equal to null. What does that mean?
There is no student inside.
No student found, right? So message box dot show no student found. Okay, else we can do message box dot show dot toString and show all the information for the student. Okay, so this will be our typical search code if the data is stored inside the university, right? Let's, to make it proper, okay, suppose once we created it, it was lowercase st list, and then we have a public property over here, which is called st list. So from outside of this class, we will only be access it as through the object. So if the university object is created in the beginning of the form, so it's available in the class form. Okay, then over here this will be u1 dot, right? Because we have to, the university object has the st list. Okay, so anyway, so the main point is every time we wanted to search something for a student, we have to write a loop over the entire st list. If we find it, we say, report the information. Otherwise, we say that ID does not exist, right? Okay, now let's pretend somewhere else in your form or another form, you wanted to look up students or all students with a last name, with a certain last name. So instead of the ID, you wanted to search for the last name, okay? So again, can you write this type of code? How will it change if we wanted to search for the last name?
It needs an array or
So
an array
this will basically become st dot last name equal to, right? If we break out of the loop, then it will only return the top student, right? Otherwise, we can create a match list over here and keep adding it to the match list, which will be an array list. And then we can report all students that match with the particular last name, right? Very similarly, what if we wanted to know all students who had a test score between 80 and 90, okay? We can write another loop like this and, you know, modify it a little bit. So as you can see, looking for information essentially requires looping over the code, okay? Now, one of the concepts in modern software development is that you should try to make client's job as easy as possible. By client, I mean the user of your class. Okay, so we created, let's pretend the student class, the university class, right? Whoever is using our university class, if they have to keep writing this type of code anytime they wanted to do the search, and like I said, what if we needed, you know, 10 variations of this idea? Then 10 times somebody will have to write this type of code. So can we make the end user's life easy so that they don't have to write this type of a looping code? All they write is something like this, U1 of 239858, and it will give them the student they want, okay? Or it will give them a null, okay? Same way, what if they said U1 of Baker? It will give us all students which have a last name of Baker, right? Or U1 of, let's say, test score 85. So if we can provide some capability like this, so that the user of our code, meaning whatever application we are creating to search for a student, the code only is one line of code, okay? Then somebody will really appreciate the way we have created our class, right? Okay, so the whole idea is don't have the end user, meaning our user interface, write the looping code. Move the looping code over here inside the class, okay? So all the search code moves over here. Okay, and then to make it even easier, provide indexer-like search capability to the user of our class. So that once again, if we created an indexer based on the last name, somebody will look up the information, something like this, U1 of Baker. Okay. Once it triggers the search code over here, of course it has to loop through, but once again, the user of our code does not have to worry about writing the looping type of search code. So makes our whole class development extremely useful to the end user. So that's the idea of an indexer, right? So let me go to the computer, show you how easy it is to create, and then I will give you an assignment. So okay, so once I launch Visual Studio, I'll go File, New Project. Okay, I'll pick a Windows Forms application, and from the location drop down 440 Fall 2015, and let me call the project Indexer Test. Okay, so this would be a small project, Indexer Test, Windows Forms application, right? Once I click OK. Okay, so now let me bring the student class. So to save time, I will bring the existing student class from our previous project. So if I right click on name of the project and say add existing item. Okay, and I go to one of our previous projects. So for example, in the first project, did we create a student class? Yeah, we did. So let me pick the student class from our first project. So by right-clicking and choosing Add Existing Item, I'm able to bring the student class, so let me double click on it. So you can see class, student, first name, last name, ID, test 1, test 2, compute grade, right? So just a regular simple class. The namespace is first. Let me change the namespace to match our project namespace. This way I won't have to keep resolving it. So I'll change the namespace of the student class to index or test, right? And remember, anytime we add an existing item to our project, it actually makes a copy of that class, so that this is our own copy. Whatever change we make over here does not affect our existing project from where we copied it. Okay, now let's go create a university class. So if I say add new item. Okay, and if I pick a class, and let's call this university. Okay, and one of the things, as we discussed, it will have an array list of, let's call it ST list equal to new array list. Okay, and let me make this with a lowercase s. Okay, as you will see, it doesn't recognize the array list, so I will right click on it and resolve it. It's in a namespace called system.collections. So once I resolve it and changes to light blue color, then now I can right click on it, refactor, encapsulate field. Okay, so we'll create the public property. Okay, let's also put a constructor for the university. So public university. And like I said, normally we will read students from database and populate the ST list. Okay, so next week as you learn the databases, you will be able to do this part. For right now, let me hard code a few students. So I will say student S1 equal to new student. Okay, so now normally what we do is, if there's no constructor available, we will go one by one, S1 dot first name equal to whatever, right? And then S1 dot last name, okay? So now let me introduce one new concept which is available in C#, and that's called automatic construction or automatic constructors. So what you do is, even if you did not write a constructor, after the new student, you put the left curly brace and put a space bar. Automatically will give you what fields you want it to initialize. Then you can say first name equal to, for example, Bill. Then comma, if you put a space bar, it's pretty smart. It will tell you what other fields you have not initialized yet. So last name equal to, let's say, Baker, comma, let's say ID equal to 12341, comma, test 1 equal to 85, comma, test 2 equal to, let's say, 91. And once you put the semicolon, it will reorganize, or sometimes it will leave it on the same line. But anyway, so as you can see, comma separated, initialization was done. So this way, in one line, you can initialize the data without having to write a constructor inside the class. Okay. Okay. Make sure you put a semicolon at the very end. Okay. So now I will add it to my array list. So st list.add S1. Okay, and let me copy these two lines. And okay, let me call it S2. Change the data a little bit. Let's say this is Sally. last name, let's say Simpson. Okay, let's say ID 1, 2, 3, 4, 5. Let's say test 1, 88. Test 2, let's say 93. Okay, and so very similarly, I will paste it one more time and make it S3. S3, and let's say I call it John. And let's say the last name is Jacobs. And again, let me change the data 1, 2, 3, 4, 3, and 81, 77. Okay. So anyway, I have 3 students added to the constructor, right? So now, as I was discussing, we want to make the end user's life as easy as possible so that the searching could be done very easily. Okay, so inside the class now, above the last 2 curly braces, I will write an indexer to search on, let's say, student ID. So the syntax for the indexer looks like a property. Okay, so you will say public, and of course, if we are searching for a student, it will return a student. Okay, and within the end STID, public student, this, and int student ID. So the syntax is a little bit confusing, but hopefully once you've seen a few examples, you'll get used to it. So it is written sort of like a property. Okay, so that means the caller of this code will give us a student ID within the square brackets. Whatever we find, we will return that as a student. Okay, so here will be our looping code. So we will say student stmatch equal to null. Okay, and then for each student st in stlist, if st dot id equal to student ID. So we'll compare whatever student ID somebody is passing to us over here. If it matches, then what will we do? We will say stmatch equal to st and get out of this loop, right? And at the very end, what will we do? We will say return stmatch. Okay, stlist. What did I do with stlist? Oh, it's capital T. Okay. So anyway, so we have written an indexer which is capable of searching based on a student ID. So now let me show you how easy the caller's code becomes. So if I double click on the form, go to the toolbox, double click on a button. Okay, go to the toolbox, double click on a text box. Okay, so now for the text box, I will call it txt ID. For the button, I will give it a name of BTN search, and or let me call it BTN search by ID. And okay, give it a text property of search by ID. Okay, and now let's take a look and see how easy the calling code is, right? Okay, now I need to create the university object inside the form. So if I right-click on the form and view code, okay, at the top of my form class, I will create the university object. University, let's say U1 equal to new university, so that it's available to every button handler inside of our form. Okay, now if I double-click on the form, double-click on the search by ID. So as you can see, once I double-click on the button, this event handler is part of the form class, and the university object is already declared at the top of the form, right? So basically, now all we have to do is student st equal to u1 of okay, for example, 1, 2. Oh, since we already have a text box, txt id dot text. And we need to convert it to an integer, because remember, anytime we read data from a text box, it's read as a string. So using in.parse, we can read it, right? And okay, so now if st equal to null, message box that show student not found, and else. Okay, message box that show st dot. So as you can see, after the U1, within the square brackets, we are just giving it a number, okay? So that's how easy it becomes on the caller's code if the indexer was already supported inside the class, right? So if I go run it, okay, and suppose I type 1, 2, 3, 4, 5, okay, so you can see what happened. St indexer has not student. What happened? Do we have a toString method in our class?
No.
We don't. Okay, let's go to, well, we don't have a toString method, so let me just quickly add. So public override toString, and we will simply do first name plus last name plus id toString plus test one toString plus test2 dot toString. Okay. So anyway, simple toString method. Now if I try running it, okay, if I type, let's say 1, 2, 3, 4, 5, so you can see it gives us the information, right? If I give it some student that doesn't even exist, then student not found, right? Okay, so a few more minutes before I stop, so that I can finish this topic. Just like we can overload methods, we can also overload indexers, okay? So now let me write the code over here to provide one more indexer so that we can search by last name, okay? So I'll just copy and paste this code. So this is inside the university class, as you can see. Okay, so I will copy this indexer. Okay, Control V. And now this time we wanted to search by last name, right? String L name. Okay, so now can there be more than one match to the last name? Yes, right?
Yes.
So what should be the return? Should it be one student or more than one student?
It should be an
So
array.
there's a couple of possibilities. We can make it an array of students, okay? Or we can make it an array list of students. Okay, for right now, let me make it an array list. Okay, or let me make it a student array. Let's make it a student array. So a student after the, if we put square brackets, right? Okay, so anyway, what will our code look like?
Student array.
Student ST match. Now, how many matches can we have now? One or many? Many, right? If I create an array, then the problem is arrays are fixed. What if the number of matches are more than the size of the array that I create? So better thing would be to make this an array list. So if I say array list, ST match list equal to new array list, correct? And now I will loop through if I find the last name that we are looking for, correct? This last name is what we are looking for. Sorry, this should be SD dot last name, okay? Then what should we do? Add it to the
ST match list.
SD match list. Dot add ST, correct? And do we get out of the loop or we just keep going?
We keep going.
Keep going, because there could be more matches down the road, right? Okay, so now we said over here we'll be returning an array, but this is an array list where we are storing. So we need to convert this to an array. So our code that will convert an array list, you will see there's a method available called toArray, okay? But that only returns an array of objects. We said we'll be returning an array of students, right? So there's a little bit of a manipulation you need to do. You need to say type of student, because array list, remember, contains whatever we store in the array list becomes an object, right? So we are saying now convert this to an array of students, but still it will be an object array, so we further have to typecast it to a student array. So that's our full code, and I'll put it on the website. So now you can match. What if we wanted to match by last name as well as first name? Or sorry, what if I wanted to add one more indexer over here so that this will search by first name? Can I just copy this code?
Well, no, because it would be overloaded. It wouldn't know which
Exactly.
one to use.
Exactly. So remember the rule in overloading is, so if I make it first name, okay, either the number or the type of parameters have to be different. So this has first name over here, and the data type is string. We have one more indexer, so if I try to build it, it will give me a compiler error saying you can't have two indexers. C already defines with the same parameter type. So how can we do that? Sometimes search for the first name. Okay, and the answer is we can add a dummy parameter, or just put one constructor, one indexer. So let me delete the last one that I wrote. So just one more minute. Okay, and so the solution would be, okay, let's add string type. Okay, so think of this way, type, and let me just call it name. So you can put multiple parameters. So within the square bracket, now somebody will say, for example, Bill, comma, first or Bill comma last. Okay, so now over here we can say if type equal to, let's say, last, then we will do this, else, or we can say if, yeah, let me just copy and paste this, Control C, Control V, if type equal to first. Okay, see, this will be name because our parameter over here is just the name, correct? And now, what will we compare over here with?
First names.
First name equal to name, right? Rest of the code stays the same. So now this method, again, how will the caller call it? Just one more second, let me, so that this part is complete. So let me put one more button over here. Okay, let's call it BTN search by name. So BTN search by name. And search by name. Okay. So anyway, I'll just hard code it. So let's say student st equal to u1 of. Okay. So for example, if you were trying to search for Baker, you will say last. Okay. And then if it comes back as an object, oops, last. And remember, it was returning an array, right? So you will have to call it STA. If you were trying to search for first name, you will do something like this. Student, let's say ST F equal to U1 of, let's say, Sally. First. So now, as you can see, the search becomes extremely easy. So that's the concept of indexers. Okay, I'll put an assignment on the website related to the indexers, and we'll continue from here.
Professor, about the previous